Hello and welcome. I think everybody can hear me. Yes. So you may be wondering, like, how can we train models? How we can do inference? And that's about the talk we're going to give today. Like how you can train foundational models on AWS. So we're going to start by talking about like how the model complexities, the number of parameters, like evolve across the years. What is AWS generative AI stack looks like? What kind of tool can you use? What kind of services do you use? And then we will move like toward like how do you orchestrate ML training on AWS, and talk about services and like reference architecture to do that. Then to conclude, we will move to more like a story from NinjaTech and how they leverage AWS Trainium for training and inference. Machine learning at scale has evolved like since 1957, right? So where we started with perceptron models, and then with AlexNet coming with like 62 million parameters. So the number of parameters just continue to exponentially grow in order to better understand complex problems or multiple tasks at the same time. Math, language, and that's why we have those now models with like trillions of parameters in 2024. And we're going to see that grow in order to have a better understanding from those models of what things that are around us. In order to train those models, we need to have a very high computational need, like petaflops needs. When we started with GPT, like in 2017, we were on around of like 10,000 of petaflops, right? And this demand is growing with like the definition of and complexity of those models. Like for example, GPT-4 requiring like hundreds of billions of petaflops in order to be trained. And those models take days or even months to be trained. So that's what the complexity is growing and how those models are evolving to have a better understanding around us. AWS generative AI stack to train those models, we start with the infrastructure. So infrastructure meaning like GPUs, Trainium, Inferentia for inference, Amazon SageMakers, Ultra clusters from EC2, EFA for networking, Amazon EC2 capacity block in order to reserve your capacity and use it when you need to be training your model and release it when you don't need it at the end of the time, and Nitro because it's so important to have acceleration. On top of that, we build extra layers. Those extra layers are, for example, Amazon Bedrock that facilitate you the use to build and solve your use case for inference and focusing on that. And on top of that, you have all the application like Amazon Q Business, Amazon Q Developers, Q Insight, Q Connect that basically extract automatically insight from all the content you can build. So today, we're going to focus primarily on infrastructure, like GPUs, Trainium, and how the overall thing works, mainly for training, because that's what we have seen from customers, of the train models and what kind of tools are using for doing those trainings. So let's start by the accelerated computing stack and what kind of instances you have on AWS. You have a very wide choice of instances. So a couple of years ago, we launched P4D, and P4D that are the NVIDIA A100 GPUs. Last year we launched P5, this year we launched P5e with H100 and H200 GPUs from NVIDIA and the second generation of EFA, where we really improve the throughput and also the latency that is kind of critical for those machine learning training workload. We also launched like Trainium 1N with enhanced networking, with EFA v2 in order to train models as well. And also on AWS, you have also the ability to use other type of GPUs infrastructure or Inferentia for inference. Meaning like on AWS, you have a wide choice for training and also for inference. Once you have finished building your models, you need to serve those models in order for your customer in order to consume them. So that's how with like G5 instances, G6 instances and G6 instances that have larger memory, that can accommodate larger models, that are one of the challenges for inference serving. And also Inferentia 1 and the second generation of Inferentia 2 that deliver better performance per cost. And all those things are coming together. They are coming together through ultra clusters. So I don't know if you have heard about ultra clusters. Basically, this is like a petabyte scale fabric network infrastructure that are dedicated to those trainings, dedicated to basically setting up the infrastructure for Trainium, for GPUs, in order for running training. The second generation of EC2 ultra clusters brings 16 times better scaling and lower latency with the second generation of EFA. And also we are reducing the number of hop of distance in this fabric in order to make sure the latency is very consistent with EFA and Nitro, but also with like the design of the network that change a lot. Also, the ultra clusters are really tightly integrated with like FSX for Lustre as an example, like very fast storage in order to read the data, store your output, and also checkpoint your models. Because those model training take forever, and sometimes they have failures that we're going to talk about that are really critical. In order to handle those failures, you need to save time to time those data in order to resume your training that's going to last. So a good example of that, if you look at some paper from Meta, like Llama 3, 4, or 5 took like 54 days of training. And if you look at the number of interruptions they were having, they were interruptions every 3 hours on average, if you look at the number of interruptions they were having. So that's why training is so hard, and training with ultra clusters and all the components are very hard. But how do you orchestrate that? How do you handle failures? How do you train those models? What type of services you need to do? Now I'm going to hand over to Ankur, that's going to talk about like what type of orchestration you have for ML training on AWS. Ankur?
Thank you, Maxime, for a great introduction on how to set up your infrastructure for large-scale distributed training. In the next few slides, I'll be talking about how do we actually create our infrastructure and what services we can use, and just more on the how-to steps to like create large clusters, run your training jobs, and monitor and observe and control your training jobs. So Maxime and I, we belong to this team that help customers with large-scale distributed training and inference for customers which we call as self-managed. What that means is if you are a customer who is not really using a fully managed service MLOps platform like SageMaker, and you want more control over how you are creating and managing the life cycle of your infrastructure using core services like EC2, S3, FSX for Lustre, that's our team. And so we have been helping customers to create clusters with Amazon EKS, if you are a Kubernetes shop, parallel cluster if you are more familiar with Slurm. Typically, more startups are familiar with Slurm, and like enterprises are more heavy on the Kubernetes side of things, or if you are using AWS Batch to orchestrate your training. So these are the three different options, and we solved a lot of customer problems in the last 4 or 5 years, which helped us to learn a lot of lessons on what customers need when they were creating these large-scale infrastructures. So these are the few things or the key customer points or pain points that they have when creating their clusters. So one is cluster provisioning and management. So what that means is it's already difficult to create a large-scale cluster, let alone manage the life cycle of it. So customers, so typically what happens is you accept like a capacity reservation in some AZ, right? Let's say you want 16 or 60 P5 instances in some AZ, and you accept a capacity reservation. If you do not have the right scripts in place to create your VPCs, to create everything that you need to set up your cluster properly, you might lose weeks or maybe a month before you have the right setup in place so that you can run distributed training or distributed workloads which are performant. Because sometimes like a networking issue may pop up, or some other issue with the storage may pop up, and it can show up as weird nickel errors, and that might take a long time to really debug the performance of. Right, so cluster provisioning and management is really important. So with this, we put in a lot of efforts to sort of democratize it, meaning that you can You have all of the scripts ready for you in one place, and you can go through in a couple of clicks to have everything that is necessary to create your public and private subnets, your S3 buckets, your FSx1 luster, and your all your compute nodes on the same spine, so that you have your cluster ready to go in just a few minutes. The next issue that the customers had was about infrastructure stability. Now imagine you are running distributed training workload of thousands of GPUs. One GPU across any node fails and your entire training run stops, right? So, and then you lose a precious time and lose a lot of money just because you are identifying a issue. Now that issue could be software driven, or some kind of driver version issue, or some kind of hardware issue as well, right? So what we have focused on developing infrastructure that can be resilient to GPU failures. So like Maxime mentioned, the Llama paper which showed a high percentage of failures were caused because of GPU failures. So you really need infrastructure that when you are working on very large scale, a failure happens, then a node should ideally be removed from your cluster and get replaced from a healthy set of nodes, and your training should automatically be resumed from the last known checkpoint, right? So we'll talk more about that. And finally, the distributed training performance. So as AWS solution architects, one of the key questions we get from our customers that, hey, we run distributed training on our on cluster and fine, but when I run on the cloud or on AWS, I run into performance issues. So what are the right settings for the environment variables, for EFA, for AWS OFI Nickel plugin? What do I need to set that gives me the optimum performance? So we have created recipes and like Docker files ready to go for which are tested for performance on P4D and P5 instances, and now the latest P5E and P5EN instances, which you can readily use for your training jobs, right? So cluster provisioning and management, infrastructure stability, and distributed training performance were the three key pillars on which we used to make enhancements to create the service what we call a SageMaker Hyperpod. Now there are a whole lot of other sessions on Hyperpod which go in more detail about the architecture, but these are the key points of it, right? So we focus a lot on performance. So that means that typically like a Hyperpod, the way it works is like this. Let's say you are interested in testing out Hyperpod, right? And all you need to do is work with the account team, and you tell them that, hey, I need 16 or whatever number of P5 nodes in the next 1 week, and I need the nodes to be in this AZ, right? And all we need to do is map book an onboarding session with you for like an hour, and by the time the day of the onboarding session, you get to accept the capacity reservation, so you start getting billed. And on the same day, we have the onboarding session in which the first 30 minutes we walk you through a workshop where you create the cluster. So in the first 30 minutes of the hour session, you will be able to create the cluster, and the next 30 minutes you will be able to run a distributed training workload. So by the time we are done in the first hour, you will be using all the 16 P5 nodes that you requested, and you made sure that they are working, networking, storage, everything is set up correctly so that you are running your workload. And then you can go ahead and optimize that workload. We will share scripts on, if you are less familiar with Slurm or Kubernetes, then we have scripts that, if you, let's say, want to submit Kubernetes jobs for Nemo on EKS. So if you want to use some of these sort of popular distributed training learning frameworks, if you are using vanilla PyTorch or something else like Mosaic ML or TensorFlow or JAX or whatever you want to use, we have some scripts for Slurm or Kubernetes that you can just take and modify it for your workload and go with it. Resilience, like I said, for Hyperpod, there is a flag for auto-resuming jobs. So all you need to be responsible for is saving the checkpoints at a pretty good frequency. And then if you want a particular job to really auto-resume, then you can just put an auto-resume flag in your submission command, and that will, what that does is, there is a service in the Hyperpod service. We do continuous health checks for all the GPUs across all the nodes, and whenever we find some GPU that's bad, a node gets taken out from the cluster, and then there is a spare set of nodes from which a healthy node gets added back to your cluster. And once that process is complete, the job gets auto-resumed from the last known checkpoint that you're saving in FSX for Luster or S3 or wherever. Right, so that's the point of the self-healing clusters and the resilience feature of it. Then ease of use and flexibility. That piece is, if you are running distributed training on a on-prem cluster, Slurm or Kubernetes, you should be able to do exactly that on Hyperpod, except some edge cases. So we have managed Slurm and EKS clusters. We provide full SSH access. So for example, if you are working on an EKS cluster, it can get sometimes cumbersome to really SSH into your compute node, right? Because you have to create a container, you have to run a pod, then you have to execute into the pod. But here we give you pure SSH access into the node, so it's much easier, a single line command that you can click to SSH into the compute nodes if you're working with EKS. And yeah, flexibility to customize training environment. So like I said, anything that you are working in your on-prem cluster, you should be able to run on a Hyperpod cluster here. One additional thing, key between, let's say, an EKS cluster or a parallel cluster with Hyperpod is nodes are using on EKS or parallel cluster, they show up in your EC2 compute, right? Because they are in your account. In Hyperpod, the nodes don't show up in your account because they are in the service account. So you will have to see the nodes in the Hyperpod console, where you can see the node, you can SSH, and you can find other details on the cluster as well. Yep. Okay. So this goes a lot into the architecture of it. So like I said, the compute nodes are actually lying in the service account, right? So you will not see, once the Hyperpod cluster is up, you will not see those nodes in your EC2 account. Then we typically work with engineers or researchers who are really just submitting jobs. They are not responsible for maintaining the cluster. Or sometimes we are working with the infrastructure team of our customers who are really responsible for creating and managing clusters for their data scientists and researchers, right? In the workshop, or rather in the onboarding session, we typically need a person from the admin and the operations team from the customer to actually create the cluster for the customer, right? So what this architecture shows is, so we have the compute nodes, which could be the P5, 48x large, P4D nodes, and then you have a head node and a login node, right? So a head node would be nodes that can be used to execute anything on the cluster. So for example, you can submit your training jobs. You can delete nodes or restart nodes. So you have control in the head node to edit anything on the cluster. If you are an infrastructure team and you just want the engineers and the data scientists to run jobs and submit jobs, but not focus on, not give them access to delete the nodes or restart nodes in the cluster, then you can use the concept of a login node, where a researcher or a scientist can just log in, submit job, and log out. This is designed for multi-user access as well. So setting up clusters for multiple users with POSIX and all is quite simple. Then you have all your data. Your data S3 will be your data. Your data backbone that will be in your account. FSX for Luster that will be automatically created will be in your account as well, and these will be talking. Your customer account will be talking to the service, the nodes in the service account via VPC peering. And then, then for observability, we have a lot of Prometheus clients who are scraping data from the EC2. And then we have the Amazon managed Grafana that can use that data to show up dashboards for you. And then we have the IAM Identity Center as well. Right, so this is the typical architecture. And yeah. Yeah, so it's yeah, one key difference here is for if you are less aware of distributed training, what we need for distributed training is all the nodes to be in the same subnet, right? So you have like, if you may be aware of like EKS setup where you can have multiple nodes in different setups. For distributed training, for the highest performance, we need the nodes not only in the same subnet but on the same spine, and which we provide with Hyperpod. And with this architecture, like I said, the key benefit of Hyperpod is within a few minutes you can have the cluster up and running in the first 30 minutes. In the next 30 minutes, you will be able to run a distributed training job where you can see that all your nodes are running. And you have, and then the next step is just make sure your data, is mapped from your S3 bucket to the FSX for Luster that got created, and then you can edit your Slurm script to run your training job, right? Okay. So we have a workshop. So in the onboarding session that customers walk through with us, and in the workshop, we show that, okay, the thing that you just ran, let's say you ran a distributed training job, you can see like live metrics from your compute nodes and your FSX for Luster and your EFA as well. You can create those dashboards, and you don't have to really do anything to do that. These in the workshop, there are like simple steps that you can follow to set up your Amazon managed Grafana, and then set up your dashboard. So what this dashboard shows is like a really large cluster of P5.48x large, which are a total of 1967 nodes. One of the nodes, and then there are a few errors on this node. So 4 rows here, it shows the number of ECC errors you are getting on each GPU. Then you have, in the yellow, you have XID errors, any thermal errors, missing GPUs as well. So there are a whole host of information that you can see on these nodes. And if you want to customize these dashboards, do that too. So we work very closely with the EFA and the EC2 teams as well. So if anything needs to be customized, we can do that. Okay. Okay. Okay, now we have our customer from NinjaTech who. Go ahead. For the slides.
Appreciate it. Okay. Can you guys hear me okay? Give me a thumbs up. Oh, yes, boy. No. Can you guys hear me? Yes. Okay, awesome. All right, so my name is Babak Pahlavan. I am the CEO and founder of NinjaTech AI. Some of you might have heard of us, NinjaTech AI and my NinjaTech AI. Probably most of you guys have not. Has anyone heard of us by any thumbs up to see what I'm working with? 1 person. Great, popular. 2. We have like a couple of you guys. Okay, sounds good. So, all right. So we have some cool stuff to share with you guys here. So we are an all-in-one AI agent for unlimited productivity. You can think of us as Netflix of Gen AI in a way. Basically, our mission is to democratize access to the world's best AI models and AI agents, starting at $5 a month, basically. We all are very familiar with the flagship products that are offered by OpenAI, sort of ChatGPT, Claude, and Microsoft and Google. I think of them as sort of like blockbuster movies, if I were to keep up with the analogy of Netflix. The price of admission is $20 to all of them. And then there's vertical specific applications like Midjourney, Breadplate if you're a developer, Leonardo, and other solutions. Each one of them costs money, essentially, right? They're not straightforward. But you may not need all of them at all once, essentially. A lot of times if you're using OpenAI, sometimes you want to use Claude, sometimes you want to use Gemini models and whatnot. This is where we come into play. Essentially with us, we're an all-in-one. one subscription fee, and you get access to all the AI models, unlimited, within reason, kind of like the telcos, but also access to lots of different AI skills in an agentic way. We make things simple and and our play is essentially productivity and making things to be very easy to use. So I wanted to quickly touch on how we do this. This is sort of an abstracted way of sort of how the system works. It's basically, think of it as a really sophisticated orchestrator engine that essentially, when a prompt comes in, and it does an intent analysis out of the gate, and then based on the type of intent that we are recognizing, we end up activating the right agent or the right system to answer the question. It's slightly different than if you're a foundation model company. Your model just supposed to do everything, although you still have to hook it up to different services. But ours is full-on agentic. And depending on sort of what's activated, essentially it either uses one of our internal models. Our core model is based off of Llama's 405B, the big one. And then also we have several other models that we use as part of our mix. Nimatron is a critique model. We also use and Pixar Sigma internally that we're using AWS's inference infrastructure for those, as well as a few other things. Or the system might be activating our super agent that I'm going to touch on. It's our next generation agentic compound AI system, as well as also you might want to just say, you know what, I want to compare my answers to Gemini or Sonnet or Haiku or other models, and we make all of that happen essentially. I guess we can do a quick little 1-minute demo video of it, and then I'm going to talk to you guys about how this magic kind of comes together. I guess this video, does it play? Maxime, let's try it. There we go. Can you guys hear it okay? The music, yeah? If you're an AWS or Amazon employee, today you can actually go to aws.myninja.ai. For everyone else, you can go to myninja.ai and you can use the product today. Everything we've shown you is live and it's fully there. So, the whole system runs on AWS. And for those who are dabbling into this world of Gen AI, I can recommend the Gen AI components and all the supporting components of AWS high enough. This is and effectively for us as a startup, especially, this has been a godsend. And we've dabbled into other cloud providers as well. So, and Maxime, can you confirm? We're not paying me to say these things, right? I'm not a paid speaker. I'm not paying that. Awesome. No, I'm not, right? So, okay, good. All right. So, effectively, AWS made our company work. Essentially, without it, probably everything we do wouldn't be affordable, because with every layer of the system, from sort of from the training part all the way to the inference part, to the serving part, to all about even log analysis or the way we store our weights, the way we store customer data, everything is sort of optimized, interconnected, and also very affordable for us. And that's something that we've been sort of we've been very lucky to have been sort of part of as AWS started to deploy more and more into this space. But just a quick word about sort of training and how training sort of works, the way to make this entire orchestration sort of system happen. It's roughly a 6-step process. Step one, and this is about to create a training plan. we first create a plan to solve a problem. So when we say we want to solve, for example, the IA part of it. If we're trying to figure out, okay, how do we detect if it's a coding question, brainstorming question, writing, image generation, soon we're going to have video and audio and other skills. First, we try to come up with a plan to say, okay, how does the model come up with an actual plan? Second, we do code generation. The entire sort of technology of Ninja is based off of code gen. We effectively, based on the plan, we come up with codes, and it's Python code. And then in step 3, we go and try to create samples of the same code, and then we do execution verification on step 3. We want to make sure that the code that we're generating actually would run. We use heavily sort of Lambda functions as well as SageMaker to make that those steps happen. Step number 4, we do verification. We want to make sure that, okay, now that we verify the code that we generated can execute, but does it do the intended function or not? Once verification is done, in step 5, we then select the right pieces, the right versions of the code that would make this function happen. We pick the highest quality ones that we've seen that the results on step 4 are the most accurate, the most closest to what we wanted to achieve. Then we store those validated samples in S3, and essentially we do, and then coupled with our user data we are serving in DynamoDB, we do a round of fine-tuning, a series of rounds of fine-tuning, such that in real time, when you use Ninja, behind the scenes, it's generating code to figure out how to do this massive orchestration that's happening across the entire architecture. The system is effectively, none of these things are pre-programmed. We're relying on code gen to figure out the right steps and the activation of the right agents in real time. And the way to do that is via the entire process that we've created. We do this over and over again to make sure that the system is actually operating in a simplified way, as opposed to us, for example, coming up with all kinds of step functions to figure things out. Right? This is the architecture that we haven't seen. I guess I'm sure others are doing versions of these things, but to us, we finally realized how to use sort of AI models to be able to make decisions in real time to activate the right tooling, essentially. So when you hear about sort of agentic architectures with tooling capability, this was our solution to make that happen, essentially. A lot harder than we thought, actually, because you hear that a lot of the Llama models is like enables tooling and whatnot, but then we realized until we did coding in real time and we taught it how to code itself to activate the right agents, things were not like production quality, essentially. It worked in a lab, but it really didn't work until we taught it how to code on its own to solve problems. And the components of AWS are used heavily everywhere. You guys probably are using CloudWatch. If not, you should be using it. This gives us insight into every step of the function for our training set, but also the training loop that we have, but also inference stuff. In fact, right as I was coming on stage, our team was debugging some issue that we had in our deployment process, and then CloudWatch was a godsend there. But effectively, CloudWatch gives you amazing insight into your system across the board. You must use it if you're using Amazon Infra. DynamoDB, crazy fast, SQL base, and the speed of DynamoDB will also enable us to do personalization as we go forward. Soon, you're going to see that results that the system is providing for each user is going to be slightly different. And that's only possible because we store your user prompt in DynamoDB. That speed matters a lot to enable personalization as we go forward for us. And of course, SageMaker. SageMaker is the ultimate orchestrator of the entire chaining of the events, and we can't recommend it enough. And if you have more of a sophisticated training job, then SageMaker and HyperPod are highly, highly recommended. And of course, once you make your weights, once you create those, S3 is the way to store it. You store it, it's cheap, it's super fast, and you can deploy it anytime you want. So we did all of that, And we were able to, as part of the orchestration, one of the things that we came up with was this concept of agentic compound AI. Effectively, how do we come up, leverage variety of AI models in order to really boost accuracy and quality? You guys are the first groups to see it. We haven't even published this just yet. It's going to be in a blog post sometime this week. The true startup fashion, we're all working weekends, and this weekend our benchmarks came together. And I'm going to show you a sneak peek of it shortly. But we have 3 flavors of our super agent. Turbo, which uses our own internally hosted models. 405B is the big one, and also we use a critique agent. Nexus is our mid-size super agent that uses the mid-size external models as well as our 405B, and Apex is the big boy. It leverages GPT-4o, Sonnet, Gemini Pro, and also we use Sonnet as a critique model in order to produce a compounding effect. At this point, we were researching for and we found out the right formula, and there's been a lot of literature recently about this as a confirmation of sort of what we've been also doing. But instead of just putting out a paper, we ended up actually building it. And this is live in the product. You guys can go to myninja.ai, use the product, and play with it. But as an example, anytime somebody does a coding question or writing question, for instance, if the super agent is active, if you're using, for example, Apex, which is available in Ultra, Ultra tier would have access to all 3 versions of it. Pro will have access to Nexus and Turbo. Standard would just get Turbo. But for example, Apex tier would get candidate answers from all 3 big flagship models, GPT-4o, Sonnet, and Gemini 1.5 Pro. Then we do a round of criticizing with 405B as well as Sonnet, actually. And then by reading all of those, then we come up with an improved answer. And we will have a much larger set of benchmarks to share by tomorrow, day after tomorrow. But on this one was ready, so I'm sharing it right now. So Arena Heart, I don't know how many of you guys are familiar with it. It's a list of 500 tough prompt questions that they evaluate the quality of chatbots. And so far, the state of the art has been given to O1 Mini by OpenAI, which, as you know, is a reasoning model. And they really knocked it out of the park when they rolled it out because Sonnet was the best in class, but then O1 Mini scored 92 out of that. But as of now, as of this last week, actually our super agent Apex is the state of the art, according to this public benchmark. That we're submitting it, and it's all up for verification. It's all can be validated. What's cool is that not only it's hitting a state of the art at 94.3, but also look at the average number of tokens that it generates in order to achieve this. So as you guys may know, reasoning models, they generate tons and tons of tokens. So economically, they're very, very expensive, but also they're very slow, right? But using the super agent approach, not only is very affordable, which goes back to our mission of democratizing access, but also it's relatively fast, actually. You don't need to wait minutes on end to get answers, essentially. We have more to share end of this week around this. Because we're noticing that across the board for coding, reasoning, and math, the super agent is actually achieving. This is something very cool. We're super proud of it, and you're going to hear more about it. But at its heart, as I was showing, it's all about sort of this capability of generating an orchestrator and be able to fine-tune our own models, which we're using AWS's infra for that. So, and this was just one more benchmark, which was pretty cool. There's this list of 13 questions. It's called misguided attentions. Have you guys heard of this question that a lot of times used to trip up LLMs? How many R's are in a strawberry? The word strawberry, or 9.11 versus 9.9, which one is bigger? Most the LLMs would just say 9.11, right? Of those so far, we're noticing that our Apex, the Ultra tier, is already scoring higher than GPT-4o, Sonnet, and Llama 405B, as well as Gemini 1.5 Pro. So this was a genuine breakthrough. that we're very proud of. But it's at its heart, it's possible with the infrastructure that AWS has enabled. So that's sort of a quick overview of what we've done. Feel free to try it out for yourself. If you're an Amazon or AWS employee, feel free to use the left side barcode. For general public, use the one on the right. And give it a shot, try it out. Super Agent is only 1 week old. We're just rolling it out right now as we speak. So, and give us feedback. The only ask that I have is as you use the product, please give us feedback and help us make it better. And that's it. Thank you so much.
One more slide. Maybe we can have the clicker. Oh. Okay, so just want to point everyone's attention to the call to action here. In the beginning, we talked about how to create our infrastructure through different services. You can find, if you are ever interested in distributed workloads and how to run them on AWS, we have this repo called Awesome Distributed Training Repo, which is a great resource for a lot of these things. It provides you step-by-step guidelines to create your VPCs, to create whatever architectures do you need with Hyperpod, with parallel cluster, with EKS, with batch, with whatever else you want. If there is a way to create like clusters, this is the repo to go for it. There are things to like customize AMIs, AWS optimized Docker files. So typically you can just look at the AWS optimized Docker files and put your stuff at the bottom of it and just use that container on P4D and P5 machines. We have an EFH cheat sheet that goes over the most common errors or issues that happen when running distributed workloads, and it gives you like environment variables that you can set to get rid of those errors. We have recipes, so distributed training examples. So Slurm or Kubernetes is scripts to run different stuff. So for example, if you are wondering on, hey, I want to run stable diffusion using Mosaic ML, there is an example for that. I want to run Nemo on EKS or parallel cluster, there is an example for that as well. So whatever, there are different ways to set up distributed training using one of these like PyTorch libraries or whatever these open source frameworks, and there is an example for that here. More detailed, like if you are running containers within Slurm, so we use NVIDIA Pixis or Enroute, so there are examples for that. We have a lot of stuff on Nemo, Mosaic ML, then we have like different ways of parallelizing stuff, so DDP, FSDP stuff, so there's a whole bunch of examples here. Then nickel tests are a common way to test if the networking is set up right on your cluster or not. So there are stuff for that. Observability, so like the Prometheus Grafana dashboards I was showing, so these have all the scripts to show how to set up your scrapers on Slurm or Kubernetes clusters. And finally, profiling. So we have a great session on Insight. So how do I install Insight? How do I generate the report on a Slurm cluster or a Kubernetes cluster? And then like how do I make sense of the report? There is another session on Insight, which is tomorrow and on Thursday. So if you are ever interested in distributed training, deep dive on performance, then that's for you. That's all I had. That's all we have. Thank you.